Hello, Mr. Gazda here. 541. You're going to need 541. You're going to need your reference table and you need a pen. Okay. So here we go. Diagram below shows a sling cyclometer. Based on the dry bulb temperature and the wet bulb temperature, what is the relative humidity? So the wet bulb temperature is right there. Wet bulb, and feel free to write it down. 15 degrees C. And the dry bulb here is 20 degrees C. Okay? That's the dry, and the key is the difference. Difference. That is 5 degrees C. So, then I go to my reference table. What am I looking for? Relative humidity. So, dry bulb of 20, difference of 5. And I gotta look at the right chart. Relative humidity, that's dew point. Make sure you're on the right chart. 20 with a dry bulb of 5. Okay, so I gotta match my columns up. Always check too. So it should be 58%. That should be a one and a multiple choice. It is. Choice 2. 58%. 2. If the base of a cloud is located at an altitude 2 kilometers and the top of the cloud is 8 kilometers, this cloud is located in the 2 to 8 kilometers. You have to know where to look. You have to know that this is on page 14 of the reference table. What was it? 2 to 8 kilometers? It's kilometers, right? Yeah. 2 to 8 kilometers. Kilometers are on this part of your scale. That's important. So 2 to 8. So this right here, you got to realize this right here is 10. This right here is 10. So it's in here. All that's in the troposphere. Troposphere only should be your answer. Troposphere only. Okay. 3. The table below shows air pressure readings taken at 2 cities in the same region of the U.S. at noon on 4 different days. So this is one of the, you really got to see what they're doing here. They have a chart. The wind speed in the region between cities A and B was probably the greatest at noon on day what? So, the same cities, different times. You're going to see the fastest wind when you have the largest air pressure gradient, which is going to be the largest difference between them. Okay, these cities are the same distance apart. So this year you have pretty much no wind because they're equal. This is off by like 2.8. This is a difference of around 10.9, and then this is a difference of about 1.9 or something. So the biggest difference between them is going to be 3 because it has the largest gradient or difference between them, and the wind will go from high to low from city B to city A. So that should be choice 3. Okay? So this is a key factor. I think there's one on the back too. Yeah, there's one on the back that is similar. So it says base your answers 1 and 2 on the weather map below, which shows a low pressure system centered on near Poughkeepsie, New York. Isobars are shown in millibars. 1. Which city is most likely to be experiencing winds of the greatest velocity? What you're looking for, and it shows the isobars here, is where the gradient is the highest, and you're going to tell by where the lines are closest together, which is similar to like when you have a contour map. The closer the lines, the steeper the slope. Same thing here. It's just the steeper the air pressure gradient. You just can't see it. So Poughkeepsie, of these cities, is going to have the highest speed, highest velocity wind. So that's what, choice 3. Choice 3. Oh, sorry for Poughkeepsie. And surface winds are most likely blowing from. Okay, key thing to know, they blow into a low pressure, Okay, and they're also curved counterclockwise. So, and this is key. Curved counterclockwise. Okay, just like this. Basically, you have to know that. Something such as this. So, Danbury towards New York City. No, that would be going from lower pressure to like a area high pressure, so it's definitely not 1. Ooh, I'm sorry, I bumped the page. Poughkeepsie towards Scranton. Nope, again, it's going from lower towards higher. That's also wrong. Binghamton towards Danbury. Ooh, that sounds about right, because maybe it's going more like this kind of curve, so that's potentially correct. Port Jervis towards Binghamton. No, it wouldn't be going this way. It would not be going that way, no way. So it has to be choice 3. Okay, that's going to go from higher pressure towards lower pressure. 3, what is the relative humidity when the air temperature is 29 and wet bulb temperature is 23? So the difference here is 6 degrees C. 29 minus 23 is 6 degrees C. Let's look in our reference table. Okay, what am I looking for? Relative humidity. Okay, so I have a dry bulb of 29, difference of 6. Dry bulb of 29. Some kids freak out like, oh my god, no 29, what am I going to do? Right? Don't give up, clearly. And I have a difference of 6, so I want to do this. Look at this. So that's 28, and that's so 28 is 59. Guess what a good guess for 29 might be? Very good. 60% relative humidity. Let's see if that's a choice. And it is choice 4. Choice 4. And then this question here, number 4, which map best represents the surface wind patterns around a northern hemisphere high pressure center? You have to know that wind is the movement of air blowing from high toward low, okay, but it doesn't move straight because wind is curved due to the Coriolis effect, which is caused by Earth spinning, Earth's rotation, and know that it gets curved. Question, curved clockwise or counterclockwise direction. The phrase is that we use is the clock is high, like on the wall. The counter is low. Therefore, low pressure counterclockwise, high pressure clockwise. Which one is out of a high? This is into a high, not this one. This is also into a high, not that one. Which one is high and clockwise? This one here, choice 3. That one's 3. That is key. It's key to know that. And around a low goes inward and counterclockwise. Know it. Trust me. Okay, Mr. Gazda, 541. Signing off. Signing off.